You're looking live at the International Space Station Flight Control Room here at the Johnson Space Center in Houston, where the Orbit 3 team of flight controllers is on duty, ready to work with a European team of flight controllers across the Atlantic as the countdown is proceeding in its final minutes for the launch of the European Space Agency's huge cargo craft, the Automated Transfer Vehicle, en route to the orbital outpost. On console at this hour here in Houston is Flight Director Jerry Jason, who is also NASA's lead flight director for the mission of the ESA resupply vehicle known as the Albert Einstein, the largest cargo vehicle in the international fleet that services the International Space Station. Named after the 20th century icon of science and the founder of the theory of relativity, the Albert Einstein is poised for launch just 36 minutes from now atop a huge Ariane 5 rocket on the launch pad of ESA's launch services provider, Arianespaces, that launch site carved out of the jungle in Kourou, French Guiana, on the northern coast of South America. For those not familiar with our ATV launch coverage, we'll be joining the Arianespaces broadcast of launch at 32 minutes after the hour, just 20 minutes before the scheduled T0 time of 4:52 and 13 seconds Central Time, which will be 6:52 and 13 seconds in Kourou just before sunset. Aboard the International Space Station at this hour, the 6 crew members comprising the Expedition 36 crew are scheduled to begin their sleep period, but you can bet your bottom dollar they'll be headed for bed a little bit late tonight so they can keep tabs on the upcoming launch and the ride of the Albert Einstein to orbit. That Expedition 36 crew is led by Russian cosmonaut Pavel Vinogradov, the commander of the station, joined by his crewmates Alexander Mazurkin, NASA's Chris Cassidy, Luca Parmitano of the European Space Agency, Fyodor Yurchikhin, and NASA's Karen Nyberg. It was just a week ago that Yurchikhin, Nyberg, and Parmitano launched to the International Space Station on their Soyuz TMA-09M spacecraft from the Baikonur Cosmodrome in Kazakhstan just 1 week ago. The final preparations for the launch of the Albert Einstein, which is the 4th in a series of 5 automated transfer vehicle cargo ships for the European Space Agency, began several weeks ago with the integration of the spacecraft with the Ariane 5 booster. The ATV-4 spacecraft propellant tanks were filled, and the vehicle was rolled out to its launch pad yesterday for the fueling of the main core stage and the upper stage sections of the Ariane 5 that occurred earlier today, setting the stage for launch. The Ariane 5 towers 168 feet in height and will be delivering to orbit not only the heaviest automated transfer vehicle yet launched, about 22.5 tons, but the heaviest payload ever launched on any European rocket. The Albert Einstein itself, the ATV-4, is filled with more than 7 tons of supplies and fuel for the station of its residents, specifically carrying 5,465 pounds of dry cargo, experiment hardware and supplies, 1,896 pounds of propellant for transfer to the Zvezda service module, to which it will hook up to and dock on June 15th, 5,688 pounds of propellant for reboost and debris avoidance maneuver capability, 1,257 pounds of water, and 220 pounds of oxygen and air. In all, 7.3 tons of cargo and supplies. Unlike a Soyuz vehicle, which is just 9 minutes from launch until the time it reaches its preliminary orbit, the automated transfer vehicle for the European Space Agency takes a bit more time to complete all of its post-launch activities. Once it is launched on the combined power of its single Vulcan 2 main engine and its solid rocket boosters, the Ariane 5 will streak away from Kourou on a race to catch up to the International Space Station, which at the time of launch will be flying 258 statute miles over the northwest corner of the Ukraine near the border of Belarus and Poland. 2 minutes and 22 seconds after launch, the solid rocket boosters will shut down and drop away, and a minute later, with the main stage engine continuing to provide thrust uphill, the fairing surrounding the spacecraft itself will be jettisoned. That will expose the ATV-4 to the regime of powered flight. Just under 9 minutes after launch, the first stage engine will shut down and separate. A few seconds later, the second stage engine will ignite for an 8-minute, 11-second burn, the first of 2 burns, raising the orbit of the ATV-4 for the start of a 10-day journey to the International Space Station. Once that first burn is completed, about 17 minutes after launch, we'll go into a 42-minute coast phase to allow the ATV-4 to drift to the correct position in its preliminary orbit. That will set the stage for the awaiting of a second burn of the second stage that will be 28 seconds in duration, circularizing the spacecraft's orbit. That second and final burn occurs about an hour after launch. Just 4 minutes later, the ATV-4, the Albert Einstein, will separate from its second stage, and 24 minutes after that, at a mission elapsed time of 1 hour and 28 minutes, its Dragonfly-style solar arrays will begin to unfurl to provide power for the spacecraft. Those solar arrays from tip to tip measure 73 feet in length. Throughout the day, the weather down at the Jungle launch site in Kourou, French Guiana, has been monitored very carefully. Some showers earlier in the day, but so far the weather is reported to be acceptable for launch. The flight control team here in Houston, led by Flight Director Jerry Jason, polled his team a short time ago. All the flight control positions were go for launch. He then communicated that to the flight director at the ATV Control Center in Toulouse, France. You're looking at that picture right now. And all of the flight control positions for the European Space Agency's industry and agency team in Toulouse also reported that they were go for launch. That was then relayed to the Russian Mission Control Center in Korolyov outside of Moscow. The Russian Mission Control Center will come into play on June 15th when the ATV approaches for a docking to the aft port of the Zvezda service module. We'll talk more about that in just a moment. As we mentioned, this is the fourth in the series of 5 automated transfer vehicles that will be launched by the European Space Agency to help resupply the International Space Station. That very first automated transfer vehicle, named the Jules Verne, was launched on March 9th, 2008 atop an Ariane 5. The next 2 ATV launches occurring in 2011. ATV-2 was named Johannes Kepler, and ATV-3, which flew last year, was named the Eduardo Amaldi. We have an animation of that launch sequence for you that's a bit more condensed than what I described just a moment ago. Again, liftoff scheduled at 4:52 and 13 seconds p.m. Central Time at the moment that the Earth's rotation will carry the launch site in Kourou into the plane of the International Space Station. 2 minutes after launch, the solid rocket boosters will separate. The first stage continues to send the spacecraft uphill until about the 9-minute mark when the first stage shuts down and separates, and then the spacecraft ultimately will separate from the second stage to enable it to drift into a position for the deployment of its solar arrays and the deployment of a communications boom called the proximity link boom that will be used ultimately by the ATV-4 as it moves into close proximity to the International Space Station's Russian segment 10 days from now. Here you're looking at the deployment of the solar arrays, and that completes the major accomplishments for today's activities, and will continue to be on the air through the deployment of the solar arrays and that proximity boom, both events scheduled at about the 1 hour, 34-minute mark into the mission. We'll be joining that Arianespaces broadcast about 8 minutes from now. At the moment, the International Space Station is flying 258 statute miles above Bolivia near the capital of La Paz, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator. The space station will move into an orbital sunset just a couple of minutes from now, flying almost directly over the Arianespaces launch site in Kourou, French Guiana, which again is located on the northern coast of South America. 10 days from now, when the Albert Einstein approaches the International Space Station, there will be tremendous interest by the International Space Station partnership. If you recall, back on April 24th, the Russian resupply ship, the ISS Progress 51, launched from the Baikonur Cosmodrome in Kazakhstan, but shortly after reaching orbit, one of the Progress's automated CORS rendezvous antennas failed to unfurl as planned, and the Progress went into dock 2 days later on April 26th with one of those antennas still folded against the side of the spacecraft. There was some very, very minor scraping detected by the crew inside the International Space Station at that time, and questions were raised as to whether or not the docking of the 51 Progress vehicle might have damaged in any way a series of navigational aids on the aft end of the service module called retroreflectors. There are 4 sets of these types of reflectors, 3 sets of long-range reflectors, and 1 set of laser retroreflectors, short-range reflectors, that are used to provide navigational data to videometers and telegoniometers that are located on the forward end of the automated transfer vehicle. They send navigational data back and forth, communicate, lock on to each other to provide range and rate of closure information for the ATV to slip into the aft port of the Zvezda service module at a rate of about 1/10 of a meter per second. Next Tuesday, on June 11th, the 51 Progress vehicle is scheduled to undock from the aft port of the Zvezda service module, with that undocking scheduled at 8:53 a.m. Central Time. We'll be providing live coverage of that undocking beginning at 8:30 a.m. Central Time next Tuesday, June 11th. At that time, video cameras on the Progress will provide the first views of the aft end of the service module and those retroreflectors to see whether or not they have in fact been compromised in any way by the 51 Progress docking that occurred back on April 26th. The real test, however, will not be known until June 15th, docking day for the Albert Einstein, when it reaches a point just 820 feet away from the Zvezda service module. At that point, called the S3 hold point in the rendezvous sequence for the automated transfer vehicle, those reflectors and navigational aids are scheduled to lock on to one another, and at that point, if there is a problem with any of those reflectors, the ATV can abort its approach and move into a parking orbit well away from the International Space Station for an indefinite period of time. There is a Russian spacewalk that is scheduled on June 24th by Fyodor Yurchikhin and Alexander Mazurkin of the Expedition 36 crew that is currently and ostensibly designed for a number of other tasks. But if for some reason the ATV cannot dock and a problem crops up that would send it into a parking orbit, aborting its approach to the International Space Station, Yurchikhin and Mazurkin then would replace a compromised set of retroreflectors with another set that was launched a week ago on the Soyuz TMA-09M spacecraft to put that navigational system back in full operational capability. We don't believe that there's a problem. A Russian analysis and a state commission that was formed after the 51 Progress launch determined, based on their ground testing, that everything should be fine with those retroreflectors on the aft end of the service module, and that the docking of the 51 Progress vehicle on April 26th with a CORS antenna folded and not deployed should have had no effect on compromising the integrity of any of those navigational aids. However, the proof will be in the pudding in the days ahead as we follow the undocking of the 51 Progress vehicle next Tuesday, June 11th, and the docking of the automated transfer vehicle, the Albert Einstein, on June 15th. We are inside 23 minutes until the launch of the Albert Einstein atop the Ariane 5 rocket from its launch site in Kourou, French Guiana. We'll be joining the Arianespaces broadcast in about 2 minutes from now. A final go for launch is expected from the launch director down in Kourou at what is known as the Jupiter Control Center in the launch complex in the jungle near the city of Cayenne, French Guiana, named the Pepper and the Pepper Sauce, named after that city. Cargo craft the automated transfer vehicle en route to the orbital outpost. On console at this hour here in Houston is Flight Director Jerry Jason, who is also NASA's lead flight director for the mission of the ESA resupply vehicle known as the Albert Einstein, the largest cargo vehicle in the international fleet that services the International Space Station. Named after the 20th century icon of science and the founder of the theory of relativity, the Albert Einstein is poised for launch just 36 minutes from now atop a huge Ariane 5 rocket on the launch pad of ESA's launch services provider, Arianespaces, that launch site carved out of the jungle in Kourou, French Guiana, on the northern coast of South America. For those not familiar with our ATV launch coverage, we'll be joining the Arianespaces broadcast of launch at 32 minutes after the hour, just 20 minutes before the scheduled T0 time of 4:52 and 13 seconds Central Time, which will be 6:52 and 13 seconds in Kourou, just before sunset. Aboard the International Space Station at this hour, the 6 crew members comprising the Expedition 36 crew are scheduled to begin their sleep period, but you can bet your bottom dollar they'll be headed for bed a little bit late tonight so they can keep tabs on the upcoming launch and the ride of the Albert Einstein to orbit. That Expedition 36 crew is led by Russian cosmonaut Pavel Vinogradov, the commander of the station, joined by his crewmates Alexander Mazurkin, NASA. You're looking live at the International Space Station Flight Control Room here at the Johnson Space Center in Houston, where the Orbit 3 team of flight controllers is on duty, ready to work with a European team of flight controllers across the Atlantic as the countdown is proceeding in its final minutes for the launch of the European Space Agency's huge Chris Cassidy, Luca Parmitano of the European Space Agency, Fyodor Yurchikhin, and NASA's Karen Nyberg. It was just a week ago that Yurchikhin, Nyberg, and Parmitano launched to the International Space Station on their Soyuz TMA-09M spacecraft from the Baikonur Cosmodrome in Kazakhstan just 1 week ago. The final preparations for the launch of the Albert Einstein, which is the 4th in a series of 5 automated transfer vehicle cargo ships for the European Space Agency, began several weeks ago with